Have you ever wondered how machine learning algorithms group similar data? Well, that's where clustering comes in. It's a type of unsupervised learning that finds and groups similar data points based on their characteristics. Clustering is a powerful tool, widely used in various fields, from customer segmentation to image recognition. In this video, we'll be focusing on two key clustering algorithms, k-means and model-based clustering. So buckle up as we dive into the fascinating world of k-means and model-based clustering. What exactly is k-means clustering, you ask? Well, let's break it down. K-means clustering is a type of unsupervised learning algorithm used in machine learning and data science. It's all about grouping similar data points together to discover underlying patterns. Now, how does it work? It starts by selecting an initial set of centers for the clusters. The number of clusters, represented by k, is chosen based on the data and the problem at hand. Once we have these initial cluster centers, the next step is assigning each data point to the nearest center. This is typically done using distance measures like Euclidean distance. Now, we have our clusters, but we're not done yet. We need to recalculate the center of each cluster, which is the mean of all data points in the cluster, hence the name k-means. But here's the thing. When we move the center, the relationships between data points and their cluster centers might change. So we repeat the process, reassigning data points to their nearest new center and recalculating the center again. This process is repeated until the centers no longer move significantly, or in other words, until we achieve convergence. The beauty of k-means clustering lies in its simplicity. It's easy to understand, implement, and it scales well with large data sets. So that's k-means for you. A simple yet powerful algorithm for grouping similar data. Now let's shift our focus to another interesting algorithm known as model-based clustering. This method is a bit more complex than k-means, but it's also more flexible and can handle a wider variety of data shapes and sizes. Model-based clustering, as the name suggests, builds a model for each cluster in the data. Unlike k-means, which assumes that all clusters are spherical and have equal variance, model-based clustering allows for clusters of different shapes and sizes. This flexibility gives it the ability to model complex data structures that might stump other methods. The process begins with the assumption of a statistical model for each cluster. These models could be anything from Gaussian distributions to more complex multidimensional shapes. The specific model used will depend on the nature of your data. Next, the parameters of these models are estimated. This could involve calculating the mean and variance for a Gaussian distribution, or fitting a more complex model using maximum likelihood estimation or Bayesian inference. From there, the likelihood of each data point belonging to each model is calculated. This is done by comparing the data point to the model and calculating how likely it is that the point came from that model. Finally, the models are updated based on these likelihoods. This might involve shifting the mean of a Gaussian distribution, or tweaking the parameters of a more complex model. And there you have it, the model-based clustering algorithm, a more flexible and sophisticated approach to grouping data. So, we've learned about two different clustering methods. But what's the take-home message? K-means clustering, with its simplicity and speed, is great for handling large data sets, while model-based clustering shines with its flexibility and sophistication, accommodating various shapes and sizes of data clusters. But let's not forget, no one-size-fits-all in clustering. Remember, the choice between k-means and model-based clustering depends on your unique data and the specific problem you're trying to solve. Happy clustering!